Good morning, everybody. So I fixed the tech issues with my Zoom, so we're back on Zoom. Thank heavens. Okay, so today we're going to continue and conclude talking about the nomenclature, and then we'll end the lecture early and turn our attention to the quiz. Okay, so we're almost ready to begin drawing structures from names. We have just a couple of more issues to deal with. Yesterday, I laid a whole lot of stuff on you guys. The substituent and priority group ending names of the various functional groups. So all of that, you're supposed to learn all of that stuff. And the only other issues that are left to talk about before we can start drawing structures from names is we need to talk about the unsaturation marker, right? And this tells if there is a carbon-carbon double bond or carbon-carbon triple bond in the parent. So remember that the systematic name of a compound has these 5 parts: stereochemistry, substituents, parent, unsaturation marker, and priority group ending. So the unsaturation marker for the carbon-carbon double bond is going to be, you're going to see either ene, or sometimes this final E is left off. So you might see just En. For the carbon-carbon triple bond, you're going to see ein, but sometimes this E is dropped. So instead of YNE, you'll just see YN. All right, so those are the unsaturation markers. Okay, next thing is the replicating prefixes. And these tell how many substituents or priority groups or unsaturations. Okay, and this is more stuff to memorize. So it's kind of similar to the meth, eth, prop, so on and so forth. So these are just ways of counting. Okay, so if there are 2 of something, 2 priority groups, or 2 substituents, or 2 unsaturation markers, the replicating prefix for that would be di. If there are 3, it's tri. If it's 4, okay, look out now. It's not going to be but, it's tetra. If it's 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. That's what I call my grandmother. And if there's 10, deca. And we could go on, right? We could go on for 11, 12, 13, however many, but let's just stop here at 10. So this is telling you how many substituents or how many priority groups or how many unsaturation markers there are. Okay, so now I think finally and at last we're ready to start naming, or ready to start drawing some structures from some compounds. So here's the step-by-step. Okay, step number 1. This is going to be find the parent in the name. And remember, the parent is the last occurrence of one of those parent syllables in the name that does not immediately follow a number or a replicating prefix. So let's just write that down just to recap, right? So the parent is going to be the last instance in the name of one of those parent syllables: meth, eth, prop, etc. The last instance in the name of meth, eth, prop, etc. that doesn't immediately follow a number or a replicating prefix. Okay, so that's a step. That's the first thing that you're doing. Next step is you are numbering the carbon atoms, right? The only thing that gets a number is a carbon atom. And so oxygen never gets a number, or does nitrogen or anything else. It always has to be a carbon atom. But if the parent is a chain, start numbering at the end of the chain. If the parent is a ring, right? So you're going to be seeing something like the cycloprop or cyclobute or something like that. It doesn't matter where you start. Doesn't matter which carbon is C1, right? So it doesn't really, when the parent is a ring, it doesn't matter where you start numbering. You can number anywhere. Okay, and so then now the next step is simply you're just writing the name, and you're and remember, you have to follow that 5-part plan of the systematic name. Okay, so I think we're ready to begin. All right, so let me show you a pretty picture. Okay, so how about let's cook up the structure of this compound. 3-cyclobutyl, 3-ethyl, 4-propyl heptane. Okay. All right. So the first thing we do is we find the parent. That's the last instance in the name of of one of those parent syllables that doesn't immediately follow a replicating prefix or a number. Okay, bute is a parent syllable, but it's not the last instance of a parent syllable in this name. So that's not the parent. Eth is a parent syllable, but that's not the last instance in this name of a parent syllable. Prop is a parent syllable, but this is not the last instance in the name of a parent syllable. Hept is a parent syllable. This is the last instance in the name of a parent syllable. And notice that this hept does not immediately follow a number or a replicating prefix. Okay, so the parent is hept. And how many carbons does hept mean? It means 7. So what I'm going to do is I'm going to take my pen and I'm going to write 7 carbons. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so yes, I could have written a boring old zigzag chain across my piece of paper. I chose not to do that because I'm writing a bond line structure and I know that I have a carbon everywhere 2 lines meet and at the end of a line that is not terminated by another atom. So there's my 7 carbons. So I found my parent. Next step is to number the carbons in the parent chain. But because this is a chain, we have to start numbering from the end of the chain. So this could be carbon 1 up here, or this could be carbon 1 up here. It doesn't matter, just as long as you start numbering from the end of the chain. So I'm going to let this be carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, and carbon 7. Okay, and now next step is now, the hard part of the nomenclature is just learning all of these substituent and priority group names. Now the name is telling you where to put what and how many of what to put where. Okay, so 3-cyclobutyl, that means that at carbon 3, I have a cyclobutyl substituent. That means a 4-membered ring. Okay, so now notice that carbon 3 is a carbon in the parent. So what I'm going to do here is I'm going to put the 4-carbon ring up here like that. Okay, so there's 3-cyclobutyl. Notice I didn't, that this carbon 3 of the parent is not one of the carbons in the substituent because every carbon atom must belong to either the parent or to a substituent. It cannot belong to both. Okay, now this is saying 3-ethyl. So ethyl means a 2-carbon substituent at carbon 3. So there's a 2-carbon substituent at carbon 3. Okay, 4-propyl means there's a 3-carbon substituent, a 3-carbon straight chain substituent at carbon 4. 1, 2, 3. Okay, so there he is. 3-cyclobutyl, 3-ethyl, 4-propyl heptate. Right, so how did that go over? Easy and fun, right? Yep. Okay, so let's look at another one. All right, so how do we do? Yeah, there he is. Okay, so now let's try this one. 4, 4, 5. Oh, that's a replicating prefix. 4, 4, 5, triethyl, 2, 2, dimethyl, 5, propyl, octane. Okay, so once again, first step is to find the parent, last occurrence of a parent syllable in the name that doesn't immediately follow a replicating prefix or a number. Okay, eth is a parent syllable. That's not the last occurrence in the name of a parent syllable. Meth is a parent syllable. That's not the last occurrence. Prop is a parent syllable. That's not the last occurrence in the name. Oct, okay, that's the apparent syllable. It's the last occurrence in the name of a parent syllable. And notice it doesn't immediately follow a replicating prefix or a number. So the parent is oct. Okay, so how many carbons does that mean? That means 8. 1, 2, 3, 4, 5, 6, 7, 8, maybe something like that. Yeah, I could have drawn a boring old zigzag. I chose not to do that. Okay, and so now the and now we number the carbons. We have to start numbering from the end of a chain. So that could be carbon 1, carbon 2, carbon 3, carbon 4, 5, 6, 7, 8. Okay, and so now we just locate the remaining substituents and place them where the name is telling us to place them. Okay, so carbon, this 4,4,5 triethyl, this is telling you that you have an ethyl substituent at carbon 4 and then another ethyl substituent at carbon 4 and then another ethyl substituent at carbon 5. Okay, and notice this is a pattern that we always see. I see 3 numbers, 4, 4, 5, and what follows immediately after? Tri, the replicating prefix. So the replicating prefix always follows the appropriate number of numbers, right? 3 numbers, then you see tri. Okay, over here, 2 numbers. I see 2 2s. And what comes right after? Die. So this is a pattern that we always see. We see the number, we see a bunch of numbers, and then what will come right next, right after that will be the appropriate replicating prefix. So this is saying at carbon 4, I have an ethyl substituent. At carbon 4, I have another ethyl substituent. At carbon 5, I have yet another carbon substituent, another ethyl substituent. So that's 4,4,5 triethyl. At carbon 2, I have 2 methyl substituents. So at carbon 2, I have 2 methyl substituents. And then at carbon 5, I have a propyl substituent. That's going to be a chain of 3 carbons. 1, 2, 3. Okay, so that's kind of a very ugly drawing, but that is 4, 4, 5 triethyl, 2, 2 dimethyl, 5 propyl octane. Okay, so when I did this earlier on my slides, I think I came up with a much prettier picture. So let me show you what this was supposed to look like, I guess. Yeah, it was supposed to look something like that. I just swung the arms in the wrong direction. 4, 4, 5 triethyl, 2, 2 dimethyl, 5 propyl octane. Okay, so now let's go through some more examples, a bunch where we're getting into unsaturation markers and getting into the priority groups. All right, so this is 3,7 dimethyl octa 1,3,6 triene. All right, and the common name of this compound is osamine. This is found in St. John's wort. This is an herbal antidepressant, right? But if you need antidepressants, I would say go with the prescription stuff. This herbal stuff doesn't work. Okay, what's the parent? Tell me in the chat. What's the parent? Anybody out there? The parent is octa, correct. And how many carbons is that? That's going to be 8 carbons. Okay, so that's the last occurrence in the name of a parent syllable. So this time I'm just going to go with my boring old zigzag. 1, 2, 3, 4, 5, 6, 7, 8. All right, it's a chain. I have to start numbering the carbons, and I can start at on the left or on the right. It doesn't matter. I'm going to start over here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so now this is saying 3,7-dimethyl. Also, here we see that pattern again. I see 2 numbers, and what follows right after that? Di, right? You'll never see something that will say you'll never see something that is 3,7-methyl, right? It has to be 3,7-dimethyl. You'll never see 3,3,3-ethyl. It has to be 3,3,3. That's 3 numbers. 3,3,3-trimethyl or whatever. All right, so we see this pattern. Okay, so this is saying that at carbon 3, I have a methyl substituent, and at carbon 7, I have a methyl substituent. That's 3,7-dimethyl octa at 1,3,6-triene. Okay, so once again, here I see 3 numbers, and then then try right after that, triene. So this is telling you that the chain has a double bond in it, and it has 3 double bonds in it, triene. That's 3 double bonds. And when we have a double bond in the molecule, the double bond always goes from the lower number to the next highest number, right? So 1,3,6-triene means that a double bond begins at carbon 1 and goes to carbon 2. This 3 means the double bond begins at 3 and goes to 4. It never begins at 3 and goes to 2. It always goes from the number that is specified to the next highest number. So there's a double bond between 3 and 4. Okay, and then the 6-triene is telling you you have a double bond at 6, and the double bond goes to 7. The double bond always goes from the specified number to the next highest number. So that's 3,7-trimethyl octa 1,3,6-triene. Yep, so how's it going? Yes, good? All right. Okay, so now let's try this one. 1, 3, 5, trimethoxy. Okay, that's an ether. Trimethoxy 2-methyl-benzene. All right, and so this is in sore throat drops, I guess. Okay. All right. So here, what's the what's the priority group? Benzene, right? That's the the priority group. That's the last thing in the name. So this is instructing you to draw the benzene ring. And now the parent, which is benzene, is a ring. Where's carbon 1 on this thing? It doesn't matter. When the parent is a ring, it doesn't matter where you put carbon 1. So I'm just going to put carbon 1 up here at 12 o'clock, and I'm going to number, of course, consecutively, and of course, I'm going to number in a consistent direction, right? I've seen people put carbon 1 up here, and carbon 2 over here, and carbon 3 over here, and carbon, no, right? It doesn't matter where carbon 1 is, but you have to number sequentially, and you have to number in a consistent direction. Okay, 1,3,6-trimethoxy is telling you you have a methoxy substituent at carbon 1, and then you have another methoxy substituent at carbon 3, and then you have another methoxy substituent at carbon 5. All right, and then 2-methyl is saying you have a methyl substituent at carbon 2. So that's 1,3,5-trimethoxy 2-methyl benzene. Yes, so far so good? Yep, easy and fun. All right, so how do we do? Yeah, okay, very good. Okay, so now let's get into some more complicated examples before time runs out and we have to turn to the quiz. Pentane 1,5-diamine. Pentane 1,5-diamine. The common name for this compound is cadaverine. This is one of the products of the decomposition of flesh, right? And the cadaverine is very poisonous to a human being, but it's not poisonous to a vulture. That's their main food. Okay, so what's the parent? Anybody out there? What's the parent? It's going to be 5 carbons, right? Pent, that's the last occurrence in the name of a parent syllable. 1, 2, 3, 4, 5. It's a chain. So there's carbon 1, 2, 3, 4, 5. There's carbon 5. And notice this is saying 1,5-diamine. So that means that we have at carbon 1 the amine priority group, and at carbon 5 we have a second amine priority group. So there's pentane 1,5-diamine. All right. Yeah, pentane 1,5-diamine. Okay, so let's do an exciting example here. I volunteer at a homeless shelter for men in downtown Boston, and one day I went around asking the guys there, I call it N-methyl 1-phenyl propane 2-amine. What do you call it? And they were all like, what? Say what? Yeah, N-methyl 1-phenyl propane 2-diamine. What do you call it? Oh, crystal meth, right? And so what I have here on the slide here is all of the nicknames for crystal meth, right? I don't know. This is what they told me down there at the homeless shelter. Maybe they were just yanking my chain, but they said some people call it Tina, ice, tick. A kid from South Africa said that call it tick in South Africa. Anyway, so this is crystal meth. Let's cook up the structure from the name. N-methyl 1-phenyl propane 2-amine. Okay, so what's the parent? Prop, right? 3 carbons. 1, 2, 3. Okay, number the carbons, begin at the end of the chain. 1, 2, 3, could have numbered them in the opposite direction. And so now the name is just telling you what goes where. This should say amine. It should say amine. Okay, so at carbon 1, I have the phenyl substituent. What's that? That's what we call benzene when it's treated as a substituent. So at carbon 1, I'm going to tack on a benzene ring. That's 1-phenyl. Okay, at carbon 2, I have the amine functionality. So at carbon 2, I'm going to tack on the amine functionality. And remember, nitrogen forms 3 bonds when it's neutral. Okay, and now the wrinkle here in the name of the amine is that N-methyl. N-methyl is telling you there's a methyl substituent on the amine nitrogen, right? So the numbers are telling you that the substituent is on one of the carbons of the parent chain, but we have a methyl substituent that doesn't live on one of the carbons of the parent chain. Instead, it lives on the nitrogen atom of the amine. So I put that's N-methyl, and nitrogen forms 3 bonds, so there must be a hydrogen over there. Okay, and so there's the structure of crystal meth. N-methyl, 1-phenyl, propane, 2-amine. All right, so let's do some more. Yep. Skip that one. Okay, so let's try this one. Oct 1-ene 3-one. Oct 1-ene 3-one. Okay, have you ever noticed that your hands stink after you handle money? Well, why is that? Well, that's because all money, paper money included, has metal ions in it. And the metal ions can furnish oxidation and reduction equivalents. Your hands are normally covered by perspiration and oils. And the metal ions in money oxidize and reduce the fats and oils on your skin, and the decomposition products have a bad or distinctive aroma. Okay, so let's cook up the structure of this name. Okay, so what's the parent? Oct, 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1-ene is telling you that, okay, so numbering the carbons here, 1, 2, 3. 1-ene is telling you there's a double bond that begins at 1 and goes to 2. And 3-one is telling you that's the priority group ending of the ketone. So that means put a ketone at carbon 3. So that's oct 1-ene 3-one. All right, so more. Yeah, oct 1-ene 3-one. Okay, so here's the bombardier beetle, and his defense mechanism is that he shoots out a jet of boiling hot water out of his anus. Can I say that? I guess I just did, right? When this beetle feels threatened, it shoots out this boiling hot stream of water out of his anal opening. And where does that hot water come from? It comes about as a result of this reaction where benzene 1,4-diol combines with hydrogen peroxide to make cyclohexa 2,5-diene 1,4-dione. All right, so let's cook up the names. Let's cook up the structures of these compounds. Benzene 1,4-diol. So benzene looks like this, right? Number the carbons in benzene. That could be carbon 1 up here, 2, 3, 4 down there at 6 o'clock. 1,4-diol. Ol is the priority group ending for the alcohol group. And this is telling you that you have an OH group at carbon 1 and you have another OH group at carbon 4. So that's benzene 1,4-diol. Okay, over here, cyclohexa 2,5-diene 1,4-dione. What's the parent? The parent is a 6-membered ring, cyclohexa. All right, and where's carbon 1 on this thing? Doesn't matter. I'm going to put carbon 1 there. 2, 3, 4, 5, 6. Cyclohexa 2,5-diene means I have a double bond at carbon 2 going to carbon 3. I have another double bond at carbon 5 going to carbon 6. That's the unsaturation marker. And at carbon 1, I have a ketone, and at carbon 4, I have another ketone. So that's cyclohexa 2,5-diene 1,4-diol. Okay, so let's do some more. Yeah. Okay, so so this is the one of the ingredients of this perfume, Chanel number 5. This has an S in it. Let's just forget about that for now. That's a stereochemical marker, a stereochemical designation. We're not ready for that yet. Let's just go with 6-hydroxy 3,6-dimethyl heptane 1-al. Okay, so this is one of the ingredients in this very expensive and exquisite perfume, Chanel number 5. Okay, so what's the parent? 7, right? Hept. So let's draw a chain of 7 carbons. 1, 2, 3, 4, 5, 6, 7. All right, I'm going to put carbon 1 over here. 2, 3, 4, 5, 6, 7. 6-hydroxy, that's what we call the OH group when it's a substituent. 3,6-dimethyl means a methyl group at carbon 3, and then another methyl group at carbon 6. Okay, and so now here's something that I want you to pay attention to, because this is some place that people frequently make all kinds of mistakes. The priority group ending here, is an aldehyde. This is a carbon-containing priority group, right? Abbreviating everything here, I'm in a hurry. This is a carbon-containing priority group. And when the priority group is carbon-containing, you do not add an extra carbon to the parent chain. When the priority group ending is a carbon-containing priority group, 1-al is telling you, don't add an aldehyde to carbon 1. Carbon 1 is the aldehyde carbon. Repeat that. When the priority group ending is a carbon-containing functional group, that would be the aldehydes, the carboxylic acids, the amides, the ketones, so on and so forth. When the priority group ending is a carbon-containing priority group, you don't add an extra carbon. 1-al is telling you carbon 1 is the aldehyde carbon. So that's what that structure looks like. All right. Okay, so here's another example of a carbon-containing functional group. So this is the defense pheromone of the African millipede, 2-hydroxy 2-phenyl propane 1-nitrile. So this is a nitrile, and I think maybe we said last time how mammals have an enzyme that clip the cyanide group off of a molecule. And so if a mongoose or something eats an African millipede, pretty soon that mongoose is going to have cyanide running around inside its body, and it's supposed to learn from that bad experience. Don't eat any more African millipedes, right? So this is a defense pheromone. So let me ask you some pre-exam humor here, right? How do you make a pheromone? You take away his pyramid. Get it? Pheromone, pyramid. Okay, not fun. Okay, what's the parent? Prop. That's 3 carbons. 1, 2, 3. So carbon 1 is there, carbon 2 is there, carbon 3 is there. I could have numbered in the opposite direction. 2-hydroxy, 2-phenyl, right? I'm going to put PH there, right? That's the standard abbreviation for phenyl. And now, once again, the priority group ending is a carbon-containing priority group. This is telling you carbon 1 is a nitrile carbon. Carbon 1, don't add a nitrile to carbon 1. Carbon 1 is a nitrile carbon. So that's a C with that triple bond. Okay. All right. Okay. So let's do maybe a couple more. All right. Now this is going to be an amide. This is another carbon-containing functional group. N-phenyl ethane 1 amide. All right. So this is a forerunner of Tylenol. It used to be used as a painkiller, but it's way too toxic to the liver, so it was replaced by Tylenol. Okay, so what is the parent here? F, 2 carbons. I'm going to write like a mixed notation thing here. Okay, 1 amide. Amide is a carbon-containing functional group. This is telling you carbon 1 is an amide, is the amide carbon. Don't add an extra carbon, right? So N-phenyl is saying there's a phenyl substituent on carbon, on the amide nitrogen. So there has to be a hydrogen here, and this carbon, anytime you draw a C, you have to draw H's. So that would be N-phenyl, ethan 1 amide. Okay, so you know what, guys? I'm going to stop here. I still need to talk about more functional groups, but what about, let's turn our attention to the quiz now.